So what we see today about the metaverse is all is old is new. You know what I mean? So a lot of this has been looked at 2 or 3 times in the past 20 years or more like 30 years. The ability for people to collaborate has always been a strong possibility, and it was worked on very heavily by DoD and MOD in the UK, because it was recognised that simulation gave you the ability to train soldiers at less than £50,000 per flight hour.
Hello, everyone. Welcome to another episode of the Medallion Excellent podcast. Today I'm with Mike Griffin, one of the people who have been in VR the longest. And if you're new to the Medallion Excellent podcast, we cover a lot of emerging technology. So if you're curious about the metaverse or blockchain, we have a lot of guests relating to those industries. So, Mike, how are you doing today?
I'm doing well, Dwayne. Thank you for the invite. I'm very much looking forward to talk about what I'm passionate about.
Awesome. So, what are you passionate about?
That's a very good question. I've been involved since sort of the late 80s in three-dimensional graphics, and most particularly in virtual reality. I built my very first VR system back in 1986, which is a very long time ago, before it was called virtual reality. And I've done everything from systems for detecting radiation and training officers through to a virtual bicycle ride, which appeared on a news TV program in the early 90s. So been involved a long time.
Wow. So you were involved in what people are currently calling the metaverse before it was actually named the metaverse, because it got the name from the book Snow Crash. So how has it evolved since you've been in the industry?
It's it has got significantly better. There's no two ways about it. The very first system I ever built, we didn't have the lightweight displays that you have today. The OLED or TFT displays. I had to use two little black and white television sets strapped to your head to provide the image, and you can imagine it was very heavy and very painful. So things have come a long way, but also strangely the same. So things like the fact that VR headsets are still very uncomfortable for long periods of getting significantly better, but still comfort is still a major factor. But resolution has come on a long way. Tracking technology has really come on since the early days.
Yeah. So I know a little bit about the early days of VR. For example, The Sword of Damocles by Ivan Sutherland. That was one of the first AR VR concepts. And you can see black and white, and they have like information overlay. Uh, so are you familiar with Ivan Sutherland's work?
Very much so. When I first started and I was a student, I bought what is an old book now, but a very good book called Interactive Computer Graphics by James D. Foley and A. Van Dam. And in the back of that book, there was a picture of Ivan Sutherland's system that he built in 1968. And that was the inspiration for the work that I did in the early 80s. So very
Wow.
much so. He was massively ahead of his time in what he did in so many ways.
Very cool. So how was it interfacing in like a black and white OLED or black and white immersive screen? Like how does that
Lot
work?
of analog. So I mean, today, um, one of the big differences between what we had to do until very recently is cutting the cord. So you could build the headsets of years gone past, big bulky things, not that much, not that much bigger actually than some of the headsets around today, much heavier, but all of them you had the cord, which is a problem. And in those days, the signals were analog, and so you had really quite thick cables to try and transmit the information up, and you had separate cables for tracking systems and separate cables for all. You had a massive umbilical of stuff that would go to the back of your head, like something out of the Matrix. And now, of
Yeah.
course, the latest sets are all self-contained and far more powerful than the systems we had. We had about 320 by 240 or less per eye, which was really rubbish. But it's amazing what you could do with that sort of low level of resolution.
Wow. So let's go into your work. So you were working on something big in the '80s. Can you tell me more about that?
Yep, sure. So I did about 10 years at Reading University, and ran for a while the virtual reality research group there. And we built three or four interesting systems, one of which was the virtual bicycle ride, which was, again, it was a test rig that I put together to sort of prove various bits of technology. So we had a magnetic based tracking system, we had an infrared based tracking system, we had a an exercise bike that was linked up using sensors and electric fans that, as you pedaled, it would blow air over you to simulate the motion. And we wired up the handlebars, of course, so as you turn, you can actually steer a course in 3D. And the system was borrowed by the Army Personnel Research Establishment for a while to test it. So they were quite interested in how um, the moving of your body translated into how it felt moving over terrain. So there were some experiments done by APRE on that.
Wow. And what's the significance of the magnetic based tracking system and the infrared based tracking system? What's the significance?
Well, it's uh, with VR, it's all about a number of things. You want to produce a stereo picture, a different picture per eye, which your brain fuses and fools you into thinking you're seeing a three-dimensional scene. But you've got to know where you're looking, and you've got to know where you're looking really quickly, really accurately, or you get basically seasick. It's like being drunk. So if you turn your head and the computer graphics takes a while to kind of swing into view, that's one of the causes of nausea that you have on headset systems. And so what we were experimenting with was different techniques and technologies to see what would give the fastest response with the least drift and the most accuracy. And magnetics had been around for a while. So Ames Research Institute, NASA, there was a system called the Polymus Tracker, which was originally developed for coal miners to find coal miners in underground. And so there was a version of that was developed, but it was slow. So we built our own version of it. By the time I left, we were moving to infrared-based systems, which a lot of systems today use. So HTC Vive uses lighthouses and infrared transmission to receivers on a headset. We were doing it the other way around, but the principle's the same. And that was faster. It was more accurate and you got less drift. So magnetics is really not the way to go.
Wow. Was there any breakthrough in your experiments? Because you have these guys, they're riding bikes, and you're simulating the senses. So, were there any major discoveries made while you were experimenting in the '80s?
Well, we did a number of things. We should have published a lot more than we did, if the truth be told. So one of the things that the team was working on was to do with teleoperation. In other words, how to control robotics at a distance. And we had a robot arm with a set of cameras on the arm, and microphones for in place of the ear. So we built a synthetic head. We could control the synthetic head from the motion of your own head and the headset. And one of the problems that we were working on was how to get the best responses from operating systems at very long time delays. In other words, there's a lag between you doing something and the robot at the other end catching up with it and transmitting the information back. So a couple of algorithms we're working on, which got published, to do with how you fuse a remote world and a virtual world when there's a big time delay in the order of seconds.
Wow. So I can think of a few applications for that technology right now. But what were your intentions for that technology back then in the 80s?
Training was a lot of it. I mean, you had even in those days, the military were interested in exercising large numbers of people over remote sites, and the communications then were a lot slower than they are today. So that's my phone to remind me to ring you. I'm going to turn that off. So, the communications delays, particularly over things like satellite relays. So if you wanted to have a group of people working in Australia, working with a group of people in America, working with a group of people in the UK, all physically operating in the same exercise, the same simulated battle space, then there would be significant time delays between somebody in Australia doing something and somebody in the UK seeing the result of that. And so you had to try and find ways to fool each of these individual systems into not seeing the lags and jumps that you would have. Aeroplanes would be behind where they really were, that sort of thing, because of the time delay in transmitting the information. So there were tricks that you could do to get around to minimize it.
Now, at the time, did the web infrastructure, online infrastructure, was that built out enough to be of
Didn't
assistance?
exist. So I
Didn't exist.
remember I need to check on when the World Wide Web actually came into existence, but it was in its infancy when we were doing our work. So the internet was there, the ability to transmit information, but the World Wide Web was still, and the information transmission was mainly between academic institutions. So I could talk to other universities remotely, but actually. As you say, World Wide Web, Web 1 was very much in its infancy when I was there.
Wow.
Things have come on such a long way now.
Wow. And at what point did you
I had
transition
hair.
to the, oh, I thought you just shaved.
Exactly. So
At what point did you transition to working with the military? Was it around that time or?
so I was kind of on off bits and pieces, mainly project worked. So um, I left. When did I leave? 1994. I left academia and went to work for a company called Cult VR, and Cult VR was more interested in using desktop virtual reality. In other words, um, basically interactive CAD and games technology to build simulations. So a lot of the work that Cult VR was in things like architectural walkthroughs, which was very much people were very interested in that. So we built a whole bunch of different architectural visualizations for companies, people like Sainsbury's. There is a large Sainsbury's supermarket in Clapham High Street in London, and we built a three-dimensional model of Sainsbury's and the area that you could actually walk around in VR and see it. And it was used by Sainsbury's to get planning consent to build the actual shop. And today the shop is built. But we saw it first. We saw the shop
Wow.
first before they actually went and built it, including media walls. So one of the things they put on the store was very large television screens, projector screens, all the way down the shop. And we mimicked the behavior of that so that the planning people could see exactly how it looked.
Wow, that
And
sounds
then we worked
amazing.
on. I've been very lucky. I've done a lot of very interesting projects all the way along.
Wow.
So
So you're
another
telling
project.
me you were involved in a project in the 90s that replicated a real life location in virtual reality, and you were able to, or you were involved in the process of building uh, that that structure to replicate like a future building there.
Yes. So
Wow.
we had the plans, and but that was common. So what we see today about the metaverse is all is old is new. You know what I mean? So a lot of this has been looked at 2 or 3 times in the past 20 years or more like 30 years. The ability for people to collaborate has always been a strong possibility, and it was worked on very heavily by DoD and MOD in the UK, because it was recognised that simulation gave you the ability to train soldiers at less than £50,000 per flight hour. So that's the cost of an aeroplane, and you could practice tactics and simulated weapon systems without the enemy seeing what you're doing. Because if you have a real physical exercise today, there is a Russian trawler or there is a Chinese plane nearby watching what you're doing and the performance of your systems. And so if you're going to do stuff, what you want to do is you actually want to practice those tactics where nobody can see you. And the only place you can practice it is in what today is called the metaverse, what was called back then cyberspace.
Cyberspace.
So
Cool.
again,
So
change the name, still the same thing.
still the same thing. Yeah,
Yeah.
definitely. So so as far as the lessons that you've learned in your long tenure, probably like 30 years, right?
Yes, longer than that, but I'm not going to tell you how much longer.
Okay. Okay. So, what lessons can we apply to today? Because from what you're telling me, like the shopping center implementation in VR, that is still kind of cutting edge technology right now as we speak. Even with the metaverse taking off, and a lot of people really excited around that particular industry. Like this shopping center thing is cutting edge. So what else do you think will be cutting edge in this current moment in time?
Oh, that's okay. Um, so what's plagued VR and now AR since the dawn of time is the ability to produce a proof of concept. So if you go online, you will see hundreds, thousands, tens of thousands of proofs of concept, and it's very easy to cook up an application that looks like it works in augmented reality or virtual reality. But actually, to produce something that really delivers capability for a user is as hard, if not harder, probably harder and more expensive than a sort of traditional two-dimensional application. So I'll give you an example. I was involved with a desktop VR firefighting simulation, and this was a task-accurate firefighting simulation in 3D. That you could fight a fire in it as a fire commander, and the level of accuracy was sufficient that they were happy that if you passed this. So let's talk about technology. So demoitis. It's very, very easy to produce a proof of concept. There are literally tens of thousands of proofs of concept, but so it's quite easy to go to somebody and do virtual puppetry or whatever you want to do to make an application look like it's real when it isn't. And there's a huge amount of work to go from a proof of concept to a fully fledged system. So the example I'll give you is I was involved in the design and implementation of a full firefighter training system for fire officers in the UK that was used by about 85% of the fire service to train and certify their senior command teams. And it was over 1.5 million lines of artificial intelligence.
Wow.
So the visualization bit was tiny. few 100,000 lines, maybe less. But the bulk of the problem was everything else. And unless you're doing sort of trivial visualization stuff, building applications or solutions that are meaningful is very difficult. So the latest app I've been working on, which is the 3D printing one, PrintXR, the visualization bit, in other words, the ability to build an augmented reality view, position stuff, and do the taps and interactions relatively quick. Where all the time has gone is working out how to load in 3D printing files and position them and rescale them and work out how I'm going to do all the operations to make it look like a 3D printed object. And that's just all of that work is, even though this is a mainly visual app, is significantly more work than all the AR bits. So
Wow.
that's one of the things that you need. So if you're talking about the metaverse, which in my days was cyberspace, you're talking about the metaverse, then you've got a massive bulk of work to re-engineer existing applications to a form that is usable in 3D, and it's as hard, if not harder. So what a lot of people are doing today is they're just taking 2D screens and they're putting them as a floating 2D panel in AR or in VR. What's the point of that? So you might argue, well, you can put these on an aeroplane and you can have all these screens around you. Possibly true. But if you're talking about a working environment where I'm going to work 8 hours a day, I'm probably going to prefer a monitor over wearing a headset. Because even with the latest headset from Meta, which I dearly love, by the way, which is very much my favorite, the professional one, I can't wait to get hold of one. It still won't be as good as the monitor setup I have here, or as comfortable. So you've got a long way to go in terms of that. But there's massive uses.
So tell me, what do you love so much about the new Meta Quest Pro?
Well, I love the was it the Meta 2? Love that one. I play Beat Saber all the time. I'm expert and above in Beat Saber. That's how I get my exercise. So I think for me, they've improved the ergonomics, but it's the pass through. It's the ability to do augmented reality well. So if they've implemented that well, that's extremely exciting. So current solutions to AR require using either beam splitters, in other words, a semi-silver piece of stuff across the eye and a screen above, so you see through but also get reflected back up the top. Bird baths, they're called, and they're horrible, truly horrible. The other system is where you bounce the light inside a piece of glass and you use what's called total internal reflection, and then you treat the glass to cause the stuff to come through at the right angle. And those are waveguides, optical waveguide systems. They're not bright enough. And so you can't really go out in sunlight and use them. And unless you do tricks like the Magic Leap 2 does, whereby you put an LCD panel to block out some of the pixels by darkening the display, it's really quite difficult. You get this kind of ghostly view of the world, and it's never bright enough. And the field of view is really, really narrow because it's difficult to squeeze all that light down these little thin slips of glass you've got in front of your eyes. Whereas so the Meta Quest 2, the ability to have a really bright, wide screen and really integrate the real world feel, the real world scene with the virtual information, I think it's extremely exciting. So for me, that's the bit that interests me. But I haven't tried one yet.
So I have a Meta Quest 2, and what would you say is probably the more killer app? Would it be AR or VR or mixed reality altogether?
It's horses for courses. So I think long term it's got to be AR. So the ability to augment what you're seeing. I've got a couple of projects that I'm working on where so RiseRx, which is one of the projects I'm working on with the Luxembourg Institute of Science and Technology. This is about visualizing invisible risks, in this case radiation. So it is very exciting and interesting to be able to see the invisible and stop people from being hurt by things they just physically can't perceive. So AR is very good for that. So whether it's systems to enable you to see through the side of a tank, what's called transparent armor. You put a headset on, and you can actually see through the sides of the tank by using stitched cameras on the outside of the vehicle to provide greater visibility, which applies to ships, aeroplanes, for civilian use as well. That's extremely exciting. So context, spatial context of information is a whole area. It's not for everybody. So Dwayne, I don't expect the next time we talk for you to have an AR headset on and have your field of view covered with icons and graphics. I think that's a horrible way to live. But if you were canoeing or exploring, or you had a boat or a car or a very large vehicle, the ability to provide enhanced safety information and route information to make your experience safer and better, really interesting. So all these technologies have their place, and so VR is really good for training. Really, really good for that training. Visualization of structures, trying things out, experimentation, prototyping of things. AR is really good at seeing the invisible or helping you see through things or provide that spatial context. But it's not for everything. Hands-free as well. So glasses, not so much what you would call AR, but what you would call kind of like having a telly on your head, like a head-mounted display. The ability to work hands-free and do something and glance up to get information whilst your hands are occupied. There's a whole series of professions where that's useful, maintenance engineering in particular. But, it's not for everything.
Right. So, there's been a new innovations. I think Meta, they had a collaboration with Ray-Ban a few months ago, and I think that was more of a head-mounted display than uh, augmented reality. But because of Moore's law, technology is getting smaller to the point where eventually we will be able to have like AR um, AR technology in like just our glasses. Now, how do you think that would affect like our day to day life, especially if that becomes like a popular way to interface?
All right, so Moore's law. Well, we're running out of Moore's law, so let's put that one on the table straight away. So we're down to what, 3 nanometers?
It's pretty small.
Apple, I think, are 5 nanometer devices going down to 4 nanometer devices. So you're getting down to hundreds of atoms or tens of atoms wide. So in another couple of doublings, there isn't any Moore's law left. You've run out.
What about quantum computing?
Well,
Then you
that's
get to quantum level.
okay. I accept that one, but you're not going to have that on your spectacles. Okay, so you need you got to keep it cold. Not sure that will always be the case. It's really quite interesting, but right now it doesn't help you any. It really doesn't help you any. So you're going to get smaller and smaller. You've probably got, I don't know. I'm not a silicon expert. Maybe 8 times more doublings, and then you're going to run out, if not quicker than that. So there's going to be a physical size to which you can't go below, because you simply can't get the compute parts that small. Batteries is the big thing. So everybody who's used these and heat. So everybody who's used these HMDs, the one thing everybody says is, "My God, they're hot." Even the things like Vuzix blades, etc., people wear them, so they get really quite warm. And heat's not a good thing. Heat tells you two things. Heat tells you you're not using your energy efficiently. because why is it heat? Okay, so if your displays were 100% efficient, only producing light that you wanted, they'd be cold, like the light bulbs you have in your ceiling. If you remember the old incandescent light bulbs, you couldn't touch them; they were so hot. That's because most of the energy was coming out as heat, and only about 30% or less was actually physical light. Now, these LED bulbs I've got in here, they're a hell of a lot more efficient. Still warm. So you've got power consumption issues to solve. You've got compute, I think, is going to be a problem. Battery is a killer. But so I don't think it's a Moore's law thing. It is a technology thing. We're going to get better battery densities. We're going to get better materials. We're going to get better ways of transmitting light. It's a lot of work. Still a long way to go.
But how do you think that would affect just if that becomes a viral sensation? How do you think that'll affect our ability to interface with, like, because I had a theory that if we had like just these glasses that had like powerful AR um, abilities, then we can put them into car windshields. We could put them, wear them on our face, and then we can get rid of all the traffic lights. And
Right.
then like,
Let me give you a really good example, and which is the next generation jet fighter, which is being built by BAE Systems. This is going to have almost no displays in it. So when you get into that jet fighter, there'll be control surfaces, there'll be a stick, there'll be throttles, there'll be a few buttons, no displays, all been taken out. And the reason for that is everything is going through the Striker 2 helmet. So they wear basically a very advanced augmented reality set of goggles today. In fact, it's built into the helmet. Really accurate. So it's smothered. You should have a look at the videos. Absolutely smothered in sensors. So that they can really accurately position the head when you're doing high G maneuvers. -3+7 or -3+9. And the helmets are so good now, they recognize they don't need all the physical displays. So that's going to happen in military technology and filter down. And that means they're cheaper, they're lighter, and more configurable. So artificial horizon, all this kind of stuff, that big, thick block of electronics in front of the pilot, lot to go wrong. And you can't reconfigure it. It is what it is. You've got a multifunction display maybe, but they're getting rid of all of that. So that Typhoon, I think it's called, might be Tempest. I can't remember. Tempest, I think it is. So Tempest will have a full heads-up display, so a helmet-mounted display, as its primary method of control for virtually every aspect of the aeroplane. So that's going to happen to everything.
Now, is there any like weak points in that type of setup? Because if
Break your
there's
helmet, you got a lot of trouble.
no, like there has to be some sort of like secondary thing. Like there has to be like secondary windows or something. Because like not only if you break your helmet, but suppose like one of the cameras on the outside of the vehicle stops working. Like how are you gonna be able to see your way around? Like do they have any
Well,
alternatives?
I would suggest you write to them and ask them that question. No, to be serious, they are going to have a small secondary display just in case. But these planes are also being designed to be highly autonomous. So the view is that only 1 out of 3 of these aeroplanes would actually have a human inside. 2 out of 3 would have no human personnel, unmanned, which I'm not sure is a word these days. So no human personnel on board. And because of the glass display element, because humans are expensive and squashy and can't do high Gs and require oxygen and protections and all that kind of stuff, if you can remove a human from the loop, you save a lot of weight and you save a lot of cost. So the reason why UAVs are so interesting is because they don't need to be human rated. So you can use cheaper components. You don't need triple redundancy, all that kind of stuff. So the whole of an unmanned airframe doesn't require anything like the level of testing, and doesn't require the level of redundancies that a human rated system does.
Wow. So, like, what? How do you see the future once this technology really solidifies itself in our society? Like,
Okay.
how?
So in
What?
2050, when I'm 85 years old, it's very likely that I'm going to have a pair of glasses like yours, we were wearing now, which are fully augmented reality with cameras and covered in sensors and tracking, which will last all day. And I'll take them off and I'll put them on its charging stand overnight, along with my false teeth. And in the morning, I'll put them back on and I'll be able to communicate with my children and my grandchildren and my great grandchildren instantly, and they can see where I am. And I can check my vitals just by glancing up, and it'll pull all the vitals down, and I'll never be lost again. And if I'm sitting in my chair because my arthritis is acting up, I can just toggle a scene and have a beautiful beach or play World of Warcraft 57 while sitting in my chair. So uh, so the positive is you can insert between yourself and reality whatever unreality you want. The danger is you can insert between yourself and reality too much unreality. So there's always that's that problem today. So yeah, freeing ourselves from the tyranny of of a fixed reality. Quite an interesting one.
Wow. So, in a video game that I've been playing called Cyberpunk 2077, like they have, you know about that game?
Yes.
Okay. Do you play that game?
No, I don't have the. I wish I had the time. I
Uh,
used to be a massive World of Warcraft gamer.
okay. All right. Well, my question was like in Cyberpunk 2077, they've gone as far as surgically implanting these AR VR systems directly into their face, so they get rid of their eyeballs and everything, and just like replace it with some electronics. And do you think that's a possibility? Like to
Oh,
like not even be able to plug out?
people do body modifications today. So if you want to body modify yourself, is it advisable? I don't know. Probably 100 years from now, maybe. Would I do it? Would I do it 30 years from now? Possibly. But if you look at the technology in 1980 and project it through, well, where are we? 1990 and project it through to the 2020s. It's come a long way, but it hasn't come a long way. So, so if you were sitting in 1980, you would probably be quite happy to have a future pacemaker fitted. And there are people going around today who have cochlear implants and have been unable to hear any other way, and that is now a fairly normal treatment. That's happened in the last 30 years. So human body interfaces is becoming more common. And I know Musk has a view to wire into humans. It's quite tricky. So we've done quite a lot of the easy ones. So hearing hasn't got that many fibers to wire into. Um, uh, um, Pacemakers don't have many nerves to detect and don't require many sensors. But the human visual system, which is what 85% of our data that we get in, much more complicated. Hugely complicated set of fibers that come out the back of the eye. There's a lot of digital signal processing that's done in the eye. Yeah, I think it will. I think it will come. So, would I? If I lost my sight, would I have a cybernetic eye? Yes. Would I replace a perfectly good eye for a cybernetic one? Probably not.
That's. I hope they see this video in the year 2077. Hopefully, they can take some good advice.
Well, military will do it, but military will go body modification because um, the ability to communicate and operate without obvious links and everything else. So it reduces, it's more personal. So you can transmit secretly, basically. Will still be will still be a thing. So interesting to see. We are living that terrible Chinese curse. Interesting times. It's very interesting to be in the UK right now. We've had 3 prime ministers in 1 year. 5 chancellors in 1 year, and there you go.
That's big news over in the U.S. Liz Truss, she
Oh,
barely
absolutely. You must
outlasted
be
the
sitting there with your popcorn and your hot dogs, with your feet up, watching the telly, saying, "Thank God it's not us."
not as much as you guys during the Trump era.
I was. How do I put this delicately? I don't. As a matter, it is a matter of policy that we don't. I don't discuss politics of other nations because it's such a sensitive subject. But yeah, I think I agree with you on that one.
Yeah, I definitely agree. So let's talk about your what you're working on right now. Actually, before I go there, let's talk about artificial intelligence because you've also contributed in the realm of artificial intelligence as well.
That's
So
right.
in what way have you
Okay,
contributed?
so I've been involved with going back into again to the 1980s, late 1980s, early 1990s, using neural networks to categorize, of all things, industrial machinery. In other words, working out from the signals from production machinery the best operating point to set the machine to get the most throughput with the least stoppages and faults. So that was a neural net thing we did in the early 90s. Um, Recently, I've been involved with two projects. One is good old fashioned image recognition, the ability to do free text reading for asset management, asset detection, so that you don't require to mark um, objects specifically with a barcode or a QR code or put an RFID chip in there. Most stuff today has a serial number and a part number, so be able to read that reliably and efficiently. So I've been involved in work to do with that. And one of the most interesting bits was for a company called Sincere. We were processing business communications to work out whether somebody had made a decision or an action or support of an action or a decision, so that you could automatically mark up the conversations and pull out the things that you would need to do for a later date. So that was business application. So a
Oh
couple of bits
wow,
and pieces there.
wow,
I've
that's
done lots of different things. I've lived, as I say to my children, they're quite horrified. But I said, if I was to die tomorrow, I wouldn't be that worried because I've done a lot already. I've still
that's
got more
good.
to do, but I've done a lot.
Yeah, you've been on the cutting edge of like technology that's really taking over right now. I feel like this is the moment for all the things that you've been working on. It's really starting to take off and be taken seriously by investors. So
Well, DALI 2 is utterly fascinating. So if you look at um, AI, so we've not reached a singularity. A singularity being that the general purpose artificial intelligence is smarter than the human. We're nowhere near that.
right,
But we are in a situation now where if I was a graphic design artist, I would be worried because programs like DALI 2, and now you've got 3D equivalents of DALI 2. You can type in a block of text and it will render you, it will produce for you a scene from that description as a piece of artwork, and it's pretty staggering the quality.
yeah,
So you kind of theoretically know how these machines work, but it's still unnerving that they have imagination, that you can by using generative network techniques and other techniques, you can formulate a system that clearly can take text and, for want of a better description, use its imagination to create a picture for you, which some of them are brilliant,
absolutely.
absolutely stunning.
Have you have you used Stable Diffusion, which is like a diffusion model for generating images, but it's open source?
No, but that's if again on it's on my long list of to dos. The trouble
Oh,
is, I've only got a relatively short life and not enough time to do everything I want to do. But if I wasn't doing AR VR, it would be artificial intelligence, machine learning. I'd probably be a lot wealthier.
Well, I don't know. I don't know. I was looking at salaries for AI, and they don't really get paid as much as us web developers. Because I'm a web developer, and like I feel like there's more demand for us than there is for the AI guys. But maybe that'll change soon, especially since it's starting to take off.
Well, the interesting one is quantum computing. Jobs for quantum computing, they're recruiting people in university before they've even finished the courses, um,
Wow.
because there are such hot demand for it. And you're talking about like salaries of $400,000 a year because they can't get the very specialist expertise. So let's talk about
So,
quantum computing. Really interesting, but
hmm,
it is not the same as general computing. So quantum computing, if you want to search for a solution where you can take multiple routes to attack the problem, is brilliant. So the classic one, two classic ones, code breaking, and the second one is traveling salesman. So traveling salesman problem is where the example is you've got a salesman and he's got 50 visits to make on places all over the map. What is the optimum route that takes the least time and least energy to go from A to all of those points and back home again? And you can do it by brute force, not very well. Um, but a quantum computer can, in theory, search all the possible combinations and come back with the optimum path. And so, for things like logistics and problems of that sort of nature, it's a game changer. Will my phone have a quantum computing core in it? I don't see that. Maybe when I'm an old man, but I can't really see why I would have it, except possibly in the area of artificial intelligence, because combining um, a neural network approach with a quantum computer system becomes extreme. You're talking about a machine that, in theory, could learn very quickly. I'm not an expert in this. I'd like to look at this, but certainly, I think there's bound to be some major advantages of coupling of quantum neural network technology. The ability to learn and train systems very, very, very quickly to a solution. Because training a neural network is time consuming and expensive. And some of the techniques today, even the beautiful pictures that are produced, still take tens of seconds to produce them. So
wow.
quantum computing
Have
has, I
you
think, bound to have an impact in that area.
have you heard of Google Colab?
Yes, but I haven't
Yeah.
done
So
much with
pretty
it.
much, yeah. So Google allows you to train neural network models on their machines. So you just go to the Colab, open up a new notebook, and then you can start, training out your neural network models on their machines. So
But
that's pretty
that
cool.
as I understand, that's running on a classical system. I haven't looked at it recently. I have used Colab 3 or 4 years ago, but I didn't do. As I was understanding, it was running on their Tensor. Is that right? Tensor core systems, which are very interesting, power efficient, specifically designed for neural networks processors, but they're not quantum.
Absolutely. Yep. All right. Well, before we go any further, I want to go into what you're doing with Print XR. It's a very interesting concept. Wouldn't expect anything else from such a pioneer of in this industry. So tell me more about Print XR.
It's one of those dangerous areas that I built it for myself to start with. So my brother uh, got me into 3D printing. So he's a retired pharmacist who dabbles in microelectronics, if you can possibly imagine such a thing. And he bought himself a 3D printer. And I went to stay with him last year, and he printed out a milk crate, which I think I've got somewhere. And I was astounded. So I'd heard of them for several years, but I'd never really. Here we go. This is the. I've got my pens in it. There you go. So he printed that, and I saw it do it, and I was absolutely staggered at the quality. So he said to me last Christmas, "What do you want for Christmas?" So I spoke to the kids, and we all said, "How about Uncle Mark goes part shares on a 3D printer for the house?" So he put some money up, and I put the rest of it, and we spent Boxing Day onwards for 3 days building a Prusa Mark III printer, and which I now love, and I produce my own prints now. Um, and I learnt a lot from doing that. What I learnt was that there's a gap between when you design something in CAD to when you 3D print it. And there wasn't really a tool that covered that gap. So that's why. So I thought I'll build one. Shouldn't be too difficult. Well, it's not that difficult actually, to be honest. And what I wanted to do was produce a system that mimics the way a material is printed. If I show that to the camera, you probably can't see the layers. I don't know where you can see the layers on there. There's layers. If I run my nail down it, can you hear that? It's printed as a series of layers. And what I wanted to do was to mimic the layers, the print orientation, and the resolution of the printing technology, so that you could try different materials, try different print settings before you then waited 8 hours to print a milk crate or a 3D part. So that's Print XR. It's an iPad and an iPhone app. It uses Apple Reality Kit. You can buy it on the store today for the princely sum of £9.99, and it allows you to 3D print, so test your 3D prints before you commit to printing it, which is quite a useful thing.
So when you say test your 3D prints, so you have the CAD model and it'll be on your phone, so you can like zoom around it in your phone before you actually send it to the printer.
Okay, so what you can actually do is you can actually Dwayne, I'll send you some videos. So 2 or 3 things you can do. You can actually make the thing appear on your desktop. So you can hold the phone up. You can hold the phone or the iPad up, and it will then make the object appear as if it was on your tabletop. And you can look around it and peer at it and examine it. You can zoom into it and do all the usual things you'd see in AR. So classical AR object display system, which is quite useful. The other thing you can do is where you've got a physical object and you want to marry up a virtual piece onto that physical object to see whether it fits or whether you like the style of it. And you can do that as well. So, for example, one of the demonstrations I've got a 3D printed pump assembly, and most of it's been printed except for the cover plate. And you can load the cover plate in as a CAD model and position it exactly right on the physical model so you can't tell the difference. And so you can check that the cover plate prints the way that you expect it to print before you then go ahead and make it. So there's 2 or 3 really good use cases for this sort of technology. And that's what you find with a lot of these things, with VR or AR. There are 2 or 3 things that this is really useful for. And there's a whole barrel of things you wouldn't dream of using it for.
Wow. So it's accurate. The object is accurate, right? The
It
object
so
is
the so Okay, so is it to within millimeters? Yes. The problem you have with all of these systems is the tracking. So sometimes the app and the real world don't align, and you get that all the time. And you'll see it with a lot of AR systems. You're looking at something and then it'll jump or it'll slide rather disturbing. Then it'll snap back again because the tracking system gets confused. So as long as it's got a good steady track, and the system supports what's called fiducial markers. So you can print out a little marker, put the marker on the table. That acts as a very solid registration. That helps to keep the thing locked. You don't need it, but it's advised if you're doing small or detail work to have a marker. So as long as you've got some known reference, it can really solidly lock onto. It's pretty stable, pretty solid. Dwayne,
now. Can
download
you
a copy
explain?
and try.
I will absolutely will. So can you explain the gap that you were talking about earlier? Like, what what exactly is that gap between 3D printing and Yeah.
It's as
What is
simple as
what?
it could be as simple as the color. So I've got some examples. Here we go. Let me show you some examples. Here we go. The bag. In this bag, and again, you've got some examples on videos which you've got on YouTube. You can see. So that is a 3D printed little boat, and that is a gold part. And you can see on the top. Can you see those ridges?
Yeah.
Those ridges
Yeah.
are part. Those ridges are part of the print process. As the print head steps up, it prints layer upon layer, and so that's what I mean. The CAD wouldn't show those ridges. The CAD wouldn't show the lines on the part, and that if you've got small holes or gaps, for example, there, if you don't print at the right resolution, you will lose the holes, or the holes won't work properly. So,
Wow.
so what you see physically 3D printed is not the same as what's on the CAD system. So
Oh,
even the
okay.
material, so the CAD, so a lot of things like Fusion 360 doesn't know that that is Prussian orange. So what I'm working on is calibrated materials so that you know that if you load in a CAD part and you say polished nylon, it will come out as if it would look as if it was made from polished nylon. Here's a piece of nylon. I mean, again, you can perhaps see underneath it there, the layers, perhaps not so clearly. You can see it's slightly rough. So getting that, mimicking those material technologies is very useful. So particularly if you're a designer working for a client, so designer working for a client, you produce a model of a new bicycle helmet, for example, or a toy. What you'll normally have to do is do a rough draft print, send that to the client, and the client will look at it and say, well, I don't like this and I don't like that. Can you do it again? Or can you change it? And so what the designer has to then do is reprint that part and send another copy over. And that's a minimum of an hour, possibly 8 hours. So what you want to be able to do is send them the digital file and say, are you happy with that? And they go, oh, yes, I can see exactly how that's going to be printed. Fantastic. Do you sign it off and give me the check? Yes. Excellent. The final copy will be in the post. So it's about removing these steps. So see what I mean by the gap?
Yeah, yeah. That makes sense now. That absolutely makes sense. And what's been your customer reaction? Like, are they loving this product?
Um, it's uh, it's due to go live properly in 2 weeks' time at the Smart Factory Expo in Liverpool. If you're interested, Dwayne, I'll do a bit of video for you and send it to you to see what the reaction is. Fingers crossed is positive. So people who've seen it and try it say they love it. So of course I'm going to say that, but no, genuinely, for those people who understand its purpose and see it, it's very useful. It won't change the world, but it might make a little bit, like a small change for the better, perhaps. I can live with that.
Yeah, I mean, this definitely seems like it's going to really help people to actually print what they want, especially 3D printing is one of those technologies that is very useful in a lot of like ways that hasn't fully been fleshed out yet. Like right now, people are replicating a lot of things that they always wanted and never really had the money to buy. But like in the future, imagine like there's so many possibilities of how 3D printing can be applied. Um, do
Okay,
do
so
you do you, go ahead?
this really interests me. Given a choice, so if we had three technologies: 3D printing and additive manufacture, artificial intelligence, and metaverse, XR, AR, which is going to have the biggest impact? Probably 3D printing. And so where we are today is if you're producing anywhere between ones to 1,000 a year, you'll 3D print it. Um, and if you're producing 1,000 a year to say 10,000 parts a year, you might be thinking of molding, injection molding, forming, all sorts of other technologies. But what you're finding with 3D printing technology is each year the speed bar, in other words, how many parts per second you can produce or how many parts per hour you can produce, is going up and up and up. So printing technology is getting faster. And so a lot of
Well,
startups now will 3D print as much as they possibly can. because
Wow.
it's cheaper and better.
Is that Mike Griffin's law?
I don't know. It's not mine. If you wish to, but I don't think I can take. I don't think I can take. I don't think I can take the credit for that one, much as I'd like to.
Yeah.
But
Absolutely.
but you're reaching. So it's getting higher and higher and higher. So we all watch people like Elon Musk, and a lot of SpaceX technology is 3D printed. So a lot of the rocket engine parts are 3D printed. Not the whole rocket, but key parts. Aviation, catches, door handles on things like the Airbus. A lot of that's 3D printed because they're only going to ever produce 1,000 of them. And you use a lot less
Absolutely.
material. I've got a tin, I've got a biscuit tin, which has got all the scrap that all the waste from all my 3D printing. And I've done a year's worth of 3D printing, printed loads of parts. The tin is only just about full now. So it doesn't waste a lot of material. It's very, very efficient in using material. Extremely interesting technology.
It's very cool. So tell me, what, like, as far as materials, because 3D printing is gonna need like different material. Does it need different material, or does it use just one material? Like, I've been planning to buy a 3D printer for a while, but I'm not super sure how it works.
Okay, so there are several. There's about 7 different technologies. So the one everybody thinks of is filament based, or FDM, fused deposition manufacture, whereby it's effectively like a toothpaste tube. You shove like a strimmer wire of plastic in the top. You melt it and you square it out of a tiny nozzle, and you go very quickly round the part, building up layer by layer with this nozzle, squirting out this very thin amount of plastic at each turn. Um, and so you can produce. There's a lot of different plastic filaments, everything from nylon to ABS, which is sort of the car plastic, through to what's called PLA, which is the most common 3D printed material for amateurs, which is easy to print, cheap. It's not very strong, um, but the materials technology is, like everything in life, is improving. So some of the manufacturers will now produce a filament that's 90% metal, 10% plastic. So what you do is you print the part, and then you send it off to them, and they bake it. And when they bake it, the plastic disappears. The part shrinks a bit, but it's solid metal, solid steel. And so you're getting these sort of hybrid technologies. You're also getting pure steel 3D printing, which is a bit extreme, where they actually have a steel wire going into the top. They heat that up and then they squirt it. Looks a bit rough, but there are steel 3D printers that will print steel. That's just
Wow.
one technology.
Yeah, it sounds like these technologies, artificial intelligence, the metaverse, and 3D printing are going to work really well together. Especially if we
Yes.
build off that story that you told in the beginning, about like the shopping center. Like, imagine the possibilities now. The technology for the metaverse is really really good. Very, I wouldn't say super realistic, but it's getting there. Artificial intelligence is going crazy. So just putting it all together is going to be, next level. We can even probably 3D print space stations and start living in space, which would be pretty
Well,
interesting.
I mean, that's what you take, isn't it? I mean, it's not quite. So one of the reasons why I got a 3D printer is I always wanted a Star Trek replicator. You know, where you stand where Jean-Luc Picard stands next to it and says "Tea Earl Grey hot," and then it makes a sound, and then he gets a cup and the tea out of the machine, materialized from nothing. You can't do the tea, and you can do the cup. So you can say tea Earl Grey hot, and you'll have to make your own tea, and the cup will probably take a good couple of hours. But you can materialize. There's something magical about this complicated object appearing from virtually nothing, just out of the plate, this 3D object, and you break it off, and there is a usable thing. It's, it's quite remarkable. So,
Wow.
yeah.
Yeah, absolutely. Yeah. So, uh, is there anything else I know you mentioned Print XR will make its official debut soon. So is there anything else that we should be on that is on the horizon that we should be on the lookout for that
What,
has
from
you
me or
involved
from other people?
for you
Um,
specific?
from me, the that's my big thing. There is a an application which is under development, which will ship early next year, called Notero, and Notero is allegedly the Roman god of finding lost things. So it's an app that uses machine learning and augmented reality to help you in an industrial context find components and trace their way. So a sort of an improved asset management system combining the benefits of image recognition and artificial intelligence and augmented reality. So Dwayne, when I've finally got that one, once I got Print XR out the way, I'll going to finish that one off. And I'll be very delighted to give you the first look, as it were.
Wait, I've heard of Natero. Like, I don't know if we're talking about the same thing, but like I've definitely heard of a product that uses artificial intelligence and it's based on the Greek god of finding lost things. Is it Greek god or
I
Roman god?
Roman
So,
god. I better be careful
so
then. I better make sure I haven't got somebody else's. Make sure I haven't got somebody else's name. I better check that. You better
no,
scrub that.
I'm just
Rather
wondering, like
scrub it from
maybe
the video.
thing. Maybe it's the same thing. Maybe like you have a lot of hype behind this and you don't
I
even know it.
would love to think so, but I'm an old cynic about this. So I'll have to. You got me worried now. I'll have to look, see if anybody's done something.
For sure. I'll try to figure out like where I heard it and double check it with you, see if
Frighten me.
it's
Yeah, absolutely.
with you. But that sounds exciting. That sounds exciting. So artificial intelligence, um, and 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 XR. Do you throw in some machine learning in there? I mean, not
Yes,
machine learning. Do you throw some
there's
blockchain?
it's mainly visual recognition. Um, so not much learning, but at the end of the day, there is a whole area which you can use ML for, and it's a commodity now. So simple ML tasks and simple ML training, all the toolkits are there. You can do it. You can do it pretty much on device now. So in the old days, you'd have to train a model on a laptop system, but now you can do a certain amount of learning on the actual phone itself. I mean, you were talking earlier about the future, and the future being we're going to wander around with glasses on, and how do we see the world? It's already here. That's what we do every single day. So a lot of people are putting money on taking the phone out and putting it up here rather than down here. But we already spend a huge amount of time augmented. You call it something else, whatever you want to do, but in mobile phones are the most amazing pieces of technology. Up there with the wheel and fire.
Wow, super cool. So, what are your social media links so we can promote so we can so anyone who's interested could reach out to you?
So it's Mike Griffin ASL on LinkedIn. There is Augmented Solutions Limited on YouTube. I've got a Facebook page, and I have got a TikTok page, which is most interesting. I don't really understand Facebook. I still can't get my head around it. Strangely enough, the two that I seem to get the best traction on is LinkedIn and TikTok. So
Yeah,
I'm active
TikTok
on both of those.
Yeah,
Sorry?
TikTok does a really good job. TikTok does a really good job of like making your stuff go viral. I'll follow you on
Yes.
TikTok. I have TikTok too. Like some of my videos do pretty well.
I'm very interested in that as well. Dwayne, I'm very interested in any advice you've got to help me boost my channel. I'll be delighted to do the same thing. As soon as the podcast is out, I'll advertise it on LinkedIn and everything else. It'll be a pleasure to do that.
All right,
And
good.
lovely to meet you. I'm sure we'll talk again. I hope we'll talk again.
Yeah, let's stay in touch. All right.
Absolutely, will do.